live, going live, and I'm live. I think I told you guys the story of when my Prius got totaled. Did I say? I don't know if you heard that story. You gotta hear my story, not your story.
I didn't hear it. Yeah, he didn't hear what happened.
No, I know. But let me just ask you: did I ever tell you guys when my Prius got totaled?
Yes.
Okay. How I got totaled?
With the girl.
Yeah. Yeah. Did I tell you the scariest part about that entire thing? When the car got totaled by the Barnegat High School student's fault, my wife was 3 months pregnant.
Oh yeah.
Scary as all heck. Oh my gosh. Now, the unfortunate part of the whole thing was that, yes, their insurance covered it, but the money that we would have gotten for the repairs didn't cover the value of the car. It's like basically they said like, well, the insurance company's like, we can't fix it. I'm like, great. We got a certain amount, yes, which we put towards a down payment on another car. It was only about $3,000 or $4,000. But you got to keep in mind, $3,000 or $4,000 was the estimate based on the value of the Prius at the time of the crash. Real quick, we got work to do.
Like they literally full spun me. Like they smashed my window and everything.
Yeah.
I was literally.
Let me see if I can find it real quick. I'll do this real quick while we're kind of getting settled. Actually, you know what? Here's what we'll do. I'm going to tell what we're doing. I'm going to tell everyone what we're doing, and then I'm going to find you a picture. Okay. Ladies and gentlemen, just so we're all on the same page as to what's happening today. Today is day 2 of the final exam review. We are going to be continuing working through that packet, that final exam review packet. We will get through as much as we can up until about noon. And then at noon would be the intervention period, in which I'm not going to be assigning anything new. But obviously, if you owe me things, you need to get on top of that. Now, the thing that you currently have, not really owing me per se, but the thing that's kind of live right now is that there is a quizzes that I posted the other day, 2 days ago, after class, in which I said I would, where it was on sequences and series. You have 3 opportunities to take that particular quizzes. Some people have taken multiple opportunities so far, but you do have 3 opportunities to take it, and I will take the highest score. So during that intervention period, if you want to utilize that time to take your attempts on that quizzes, that is up to you. Otherwise, if you owe me things, that'd be great as well. So what I'm going to need you to do, if you can, or if you want to, open that PDF of the final exam review, that would be great because that is what I'm going to be opening up in a few minutes. But we're going to begin this review in a few moments. Now, I would like to try and find that picture. I believe I know where it is because I know the exact date.
Can I go to the bathroom?
Yeah, you can. I'm probably gonna find it before, way before you get back. You know how I know? Because there it is. I just found it. Hold on. No, I'm gonna bring it up there.
Oh.
Hold on.
Oh, you and your wife.
Yep.
Wow.
Yeah,
Oh my God.
that was the car. We got smashed right in front of Southern. My buddy there, my buddy's in a nice shirt and pants because we were going to a wedding.
Wow.
Yeah. No, actually we did. The car got towed and it was like, well, let's just be late to the wedding, you know? What else are we gonna do? But yeah, that's what I wanted to show you. You can go ahead.
You get mad at you got cars.
Yeah, I know. So it's like, oh, sorry, we're late.
That's what happened. I remember I got a car accident on the way to my parents' wedding. And my mom was like, well, we can't really do that.
So on the Google Classroom stream, there is this PDF of the final exam review, as we started the other day. We left off on we finished up problem number 8, and I would like to pick up where number 9 left off. So this is where I'm going to pick up. Let me try and get this thing set up. Is he okay? Is he okay?
Why would you do that?
I blew it off. Okay?
Where is it?
On the floor.
What is it?
It's a bug.
Oh, it's a bug? What kind of bug?
I don't
It
know.
looks like a stink bug.
No, it's not.
I lost it. All right,
Oh
close this
my
way.
God. Well, now I guess get close to
That
it
thing
right now.
moved fast. Where'd it go?
Yeah, I know.
Looks like it's crawling up on those dividers.
See you later, stinky.
Anyway,
Oh, by the way, I totally don't have to leave early tonight.
the track thing?
Yeah.
Yes. I think Paul told me about the track thing last time, right? Was it you told me about the track
It was
thing?
Jess. What
Or it was
time do we have to
Jess?
leave?
All right, my bad.
What time do we have to leave? I know the boss is at 11:30.
Because I'm running
Where did they
So I can't.
All right. Well, yeah, we'll figure it out. Anyway, we're on number 9.
The boss is at 11:30, so I might have to leave at like 11:15.
I understand. Yeah. Number 9. Number 9, I'll kind of zoom in on this. It's asking what line is the graph below symmetrical about? That's a very terrible wording of that question. That is a very terrible wording of that question, but I'm going to try and sketch this particular equation. 1, 2, 3, 4, 5. 2, 3, 4, 5. I'm going to show you exactly what I just copied down and how I can figure out precisely what this graph is symmetrical around. According to the picture, it looked like this particular quadratic went through the x-axis at +1 and +5. If I flip back, I'm just going to show you that real quick. There it is. Those are the only 2 pieces of information that I actually need in order to show what this graph is symmetrical around. It is a quadratic, it is a parabola. They are symmetric by nature, and they are symmetric around this vertex right here. This vertex exists at x equals 3. And quite literally, that is the answer to this question. It is symmetrical around the vertical line x equals 3. You could literally, I don't know what you guys did in geometry, but like when you learn like symmetry and whatever, you ever do that thing where like you fold the piece of paper in half? That's literally what this is. What is it? Where would you fold it in half? Straight down that vertical line. Number 10.
It's like a wormhole.
No.
They think that, like,
A wormhole is more of an asymptote.
they think that space is like foldable and
Yeah.
overlaps.
How do you think Han Solo was able to do the Kessel run in 12 parsecs? When 12 parsecs is actually a measure of distance and not a measure of time.
Yeah, it's like most like jumps. Like if you're going fast enough, you can break through the thing. That makes sense. Like,
Per se.
If you're going fast enough, you can break through the barrier, and then you just end up on the other side, creating a wormhole.
Per se.
Because you create your own gravity because you're going so fast.
Here's number 10.
Creating a hole in space-time.
Continuum. Number 10, the directions here are very specific. The directions are just asking for you to write this problem in an equivalent form. They say write the equivalent form of this expression. Still telling your story?
No.
I didn't hear it yet, so she's telling me for the first time.
All right, but it's been like 5 minutes.
What, the crash story? The
Yeah.
Yeah.
It wasn't my fault. It was
She's
your
a
fault.
pro at
Remember
getting
that word?
Thank you for displaying all of that. Anyway, back to this. So, to write an equivalent expression, you could take this in any number of directions. In fact, I will actually show you, I think, 2 equivalent expressions, 2 ways you could answer this. First, if you took out a greatest common factor of 2, if you took out a greatest common factor of 2, technically what I have written there is an equivalent expression. They are exactly the same. This is one way of writing the problem, or answering it, I should say. Another way of answering this problem is to factor it farther or factor it completely. Now, I don't know actually if it is factorable completely. Let me just double check that real quick on my calculators up here. Are you sure? Oh, my bad. So if I double check, I want to double check to see actually if this is factorable. Oh, it is. This one is definitely factorable. A times C would give you -21 because of the 3 times -7. I'd have to find 2 magic numbers that multiply to -21 and at the same time add up to the middle number of +4. That would be positive 7 and negative 3. I would have to organize this information into a T-chart where the magic numbers would go into the bottom. And because this is a 3x squared, I would break this up 3x and 3x. I would have to simplify that T-chart. And vertically, it would give me, I'll move this up a little bit. Vertically, it would give me a 3x plus 7, a 1x minus 1, with that 2 out front. Now, I want to be very clear about something. On Edge Elastic, which you're not taking your final on Edge Elastic, but on Edge Elastic, if you gave either of these answers, I know that Edge Elastic would count both of them as being correct. In terms of Linkit, bless you, in terms of Linkit, I'm not sure if Linkit actually has the capabilities of determining multiple answers, but I would personally make sure that Linkit gave the credit where credit is due if you gave either of these answers. Furthermore, if you were factoring this and you only got these two binomials, if you only got the 3x plus 7, x minus 1, and you did not include the 2, unfortunately, that would be wrong. The 2 is a factor of this problem. It is the greatest common factor. So you do have to put that into the answer. But that's all that the problem really asked for. It said, write an equivalent expression. Hint, factor, for number 10. That's all they wanted. Number 11. Number 11 is asking for you to divide. Last class on Wednesday, I reminded you, and I will remind you again today, but on Wednesday, I reminded you of synthetic division. Right now, all that I'm doing is I'm copying down the actual equation that they're giving to me in the problem. And they want to know what is the remainder when you divide by x plus 4. So let me show you what I wrote down. This is what I wrote down. I wrote down the actual equation, this big giant thing, and I divided it by x plus 4. What they want to know, or what they are asking for in the problem itself, they want to know what is the remainder. Basically, if I were to do some synthetic division, the only thing they want to know is what is this bottom right number? What number eventually will appear in this bottom right position, giving you the remainder of this division? The coefficients of the equation are simply written in as is. On the outside, I'm not putting a positive 4 because x plus 4, if you were to solve that, it would give you a negative 4. That's the number that needs to go on the outside. The 0 of that x plus 4. 0 of x plus 4. Synthetic division, it's nothing more than bring that first number down, multiply. These numbers are going to get a little intense. Negative 37 times 4 gives you 148. Good Lord. If I add those vertically, I get 102. 102 times negative 4 gets me negative 408. This is not a typo. These numbers are actually happening. If I take negative 408 and I add 219, I get negative 189. Multiply that by negative 4. I get positive 756. Again, not a typo here. I made sure all the negatives and positives were what they should be. Add 180. you get this ridiculous number of 936. That represents your remainder. Typically, we would love it if that number were like a 0, but unfortunately, this thing got way out of hand way too quickly. But yeah, 936. It seems like if somebody were to do that problem, they would feel like, oh, I feel like I'm wrong on that. But no, those are the numbers. That is what they are. Number 12. Number 12 is taking you back to a chapter that we haven't talked about recently. It's talking about inverses. I'm writing down the equation for number 12. They want you to find the inverse of that equation. They want you to find the inverse. Don't you got to go to track now? Oh, they did? Okay, all right, I got you. Is this Ocean County? States, okay. In terms of the inverse of a function, if you were to find the inverse of a function, I'm going to remind you of a couple things. The inverse of a function is basically undoing what the function does. If you plug in an x and it spits out a y, then you should be able to find an inverse equation where you plug in a y and it spits out the x. Every single x comma y ordered pair is reversed to become y comma x. If you were to graph this function, it would be reflected across the line y equals x to find the inverse equation. What we need to do is this. First, I'm going to replace f of x with a y. Then I am literally going to switch the positions of x and y. I am literally just going to switch their positions without changing anything else. Finally, I have to solve for y. I have to solve for y. I'm going to multiply by 5x. I'm going to subtract 4. And I can't have that negative hang out on that y, so I do have to multiply everything by -1. That means that ultimately y is going to equal -5x plus 4. This is the inverse equation. Another way that the notation may show up is like this. Instead of y, they will have that inverse notation with that x to the -1st power. If they ever ask you to find an inverse, you have to switch x and y and solve for y. That's what you have to do. That is the definition of what an inverse is. X and y switch positions everywhere, including the equation. And if you can do that, then you can find the inverse. Now, if I actually had to graph, I'll just graph these real quick. You don't actually have to do this for this problem. I just want to show you visually what this thing actually does. But here is the original equation. There's the original equation. And there is my inverse equation. Just see what they look like. There's the first one. There's the second one. It doesn't look perfect because the screen is a little warped, but they are inverses of each other. You can see that with that line cutting it down the center being a reflective line right through the diagonal. but they are indeed inverses of each other. Weird. Number 13, words, words, words. Now, number 13, I'm just going to tell you, number 13 is one of those statistics problems that they're trying to throw at you. I'm not going to worry too much about number 13. And I wouldn't want you to worry too much about number 13. But just for the sake of argument, if it's multiple choice or check all that apply, you could easily figure it out just by common sense and logic. A marketing company is conducting a survey about sports. Surveyors will call a number of households in one city to question them about their favorite sports. How should the company collect or conduct the survey in order to have an accurate collection of surveys responses relating to the preferences of the general population of the city? So, you want to find out people's opinions on their favorite sports. Name a local city. Sure. So you're living in Cincinnati and you decide, you know what, I'm going to call everybody up and see what their favorite sport is. People living in Cincinnati, what do you think they're going to respond?
I actually don't know Cincinnati sports.
They're going to say the Bengals.
Or,
Oh, football. Right?
well, yeah, they could say the Bengals, football,
No,
Are we
I
talking
don't
about
watch
football?
football.
Just like, are we talking about like
any sport,
Baseball.
or baseball because the Cincinnati Reds are there.
I don't know.
I only watch football. So.
Okay. Well, just for the sake of argument, though, there's no hockey team, there's no basketball team.
Okay, then football.
Okay.
I'm gonna say football.
Could be football or baseball. Do you see a problem with that, though? Like, look what you're trying to find
You're
out.
asking what their favorite sports is. I think you said sports teams.
No, just sports.
Okay.
But-
Probably baseball.
But is there a problem, though, with calling just people in the city of Cincinnati? Look what you're trying to find out. A marketing company is conducting a survey about sports. I want to know, hey, what's everyone's kind of favorite sport around the country? If I just call people in Cincinnati, what's the problem?
That's just one city. There's so many cities in the country. You don't get accurate.
Yeah. Everyone in Cincinnati is going to be biased towards their local teams. Whether it be like, I like football or I like baseball. Cool. I mean, it's not going to be the case for everybody. Well, yeah, they do. They were good in the 80s. Late 80s. The Bengals made it to a couple Super Bowls.
Yeah.
They lost. A guy graduated high school, plays for the Bengals right now. Right? Clark Harris. He's the Yeah. He went to Southern. A lot of random people from Southern made big names for themselves. You know the biggest celebrity sports name that ever came out of Southern?
Sport? I don't know.
Martin Truex.
Oh my goodness. I have.
He's my cousin.
Really?
Yes, we had this
Oh,
conversation.
yeah.
You're whatever married.
Yeah, my
Ha!
sister.
So me and Jess are like technically cousins.
Well, not anymore. They broke off the.
Never mind.
because he abused
This
her.
conversation went off the rails.
Okay.
So we're almost cousins.
Yeah. I forgot about that.
But you see my point though. If you only call people in one particular location, they're going to be biased to whatever sports are playing in their particular city. So the question is, how should the company conduct the survey in order to have an accurate collection of survey responses relating to the preferences of the general population of the city? You're going to really want to conduct a random sample. A random sample. If you think about it, like, think of it this way. Imagine that you are making soup. Imagine that you're putting together soup. You put in the broth, you put in the spices, you put in the potatoes or meats, and then you're like, I'm going to taste test this. Yes?
I know we said they were going to make an announcement, but people are already on the bus.
Well, yeah, that's why I offered like 10 minutes ago.
Yeah, like, Robbie and her family, like, they're all on the bus. Because, like, it leaves at 11:30.
But yeah, that's why I said like 10 minutes ago, hey, aren't you supposed to get going?
I texted my coach and he goes, they're gonna make an announcement. Like, I have to change this stuff.
Yeah, go do your thing. Anyway,
It's gonna be 11:30.
yeah. All right. Let's talk about soup, though. Think of it this way. Look. If you want to taste test that soup, you have to make sure that the soup is mixed properly. if you're going to take a random sample, you have to make sure that it is a random sample and not just the first 20 people that you call, or the first 20 people that live next to the stadium, or the people who live in one city. If you're going to conduct a proper sample, it has to be randomized. That's my whole point. Number 14, though. Again, number 13, I'm not really going to worry too much about, but number 14, let's talk about that. I'm going to write down the information for number 14, and I want to show you exactly how number 14 can be conducted. Flip, zoom out. So here's the information that they give you. They say this is a geometric sequence, but they don't give you the formula exactly as we have typically seen it. You don't have to worry about that. I'm going to show you exactly what you have to do. They're telling you that the first term is 4. Hopefully you can clearly see right here that what they're doing to each term in the sequence is they're just multiplying it by 2. Hopefully you can clearly see that, oh, it's just 2 times. In fact, the way that this notation works, a sub n, if you're going to get any term in the sequence, you take 2 and you multiply it by a sub n minus 1, which is the previous term. I just multiply by 2 each time? Yes. So the first term is 4, and then 8, there's the announcement, and 16, then 32. Okay. Hey, where are they traveling to? Okay. Delsey is out near Rowan, right? Yeah. I've driven through there a lot. Okay. Yeah. Reduce the number of people. Gotcha. Yeah. But the fourth term is 32. That's the only interpretation that needs to be done in 14. Number 15. 80 people were asked, what's your favorite color? The frequency table shows the results. One person is chosen at random. Oh, it says one person chosen at random is a boy. It says that if favorite color is independent of gender, what is the probability that his favorite color will be green? This seems too easy to be true. Hold on. Another announcement. Please report to the main lobby. You're being signed out. Number 15 is just another one of those probability problems. It's like, oh, well, there are clearly, it seems like, 38 boys? 10 out of 38? Yes. It's literally 10 out of 38. I don't even know why this is a question here. Whatever 10 out of 38 is as a decimal. Let me see what it is. 10 divided by 38. 26.3%. Not even going to bother writing that one down. I want to do something more important than that. Like number 16. Number 16 is a quintessential problem. Number 16 is a projectile in motion. Now, look at this graph that they gave you. It's a little hazy on the board right now, but of course, like I said, that PDF is available to you. That PDF is on the Google Classroom stream. That PDF you can easily load on your computers, especially for those who are in the live stream. But I'm looking at this graph. They're asking you multiple questions. First, they want to know, how long is the ball in the air? Let me zoom this in just a little bit more. There we go. I wanted to see this a little bit better. Boom. And I'll come up here for that. They want to know, how long is this ball in the air? And it's just a matter of, well, time going by. It's launched from right here, but that's 0 seconds. And it lands right over here. It's like, oh, well, how many increments is that? It goes up by like 1, 2, 3, 4, 5. So it's like 4 point something. It's not quite 4.5. It's more like 4.25. It's probably close to about 4.2 seconds. You just have to estimate that. They don't give you an equation, unfortunately. They do not give you an equation, so you can't solve anything, but you just have to utilize the graph that they give you. Part B. At what times is the ball 40 feet in the air? It is at 40 feet in the air at 2 separate times. If you were to just bring this thing down for 40 feet, again, estimating approximately what that would be, this looks about 1.6 seconds at 1.6, and this looks about very close to 3.6 or 3.5. As long as they are close, they should be fine, because honestly, all you're doing right now is estimating what that thing should be. Estimating based on the interpretation of the graph. What is the maximum height that the ball reaches? Again, we have to estimate approximately where the apex, where the vertex takes place. It's over 70. You could probably say anywhere between probably about 75-ish, I would say. Yeah, that's pretty close to 75-ish. 75 feet. Make sure you put the proper units on there. 75 feet. Does it take the ball the same amount of time to go up as it takes to go down? The answer is no. And there's a very particular reason for it. Parabolas are supposed to be symmetric. Parabolas are supposed to be symmetric. They're supposed to reflect. However, this particular object, and you can see it right here, was launched not exactly on the ground. It was launched not exactly on the ground. And because of that, it took a certain amount of time to get up and a certain amount of time to get down. It would be symmetric if that were the case, but it took a little bit extra to hit the ground. So the answer is no. Does it take the ball the same amount of time to go up as go down? No, because it was not launched from the ground. It was launched a little bit above the ground. You have to be able to properly interpret these pieces of information, these graphs. Zoom back out a little. Here we go. Oh, I'm gonna be very honest about this next question. I am not a huge fan of it. I am not a huge fan of these types of problems. Write a possible scenario to describe what this graph tells us about Jody's day. I personally think that these questions are ridiculous. But let us indulge the people who put this together, this review, and actually see what we can say about this. Again, it's just ridiculous. It says, okay, the table below shows the distance in miles that Jody is away from home at given times throughout the day. Okay, cool. At 9 a.m., she's 4 miles away from home. At 10 and 11 a.m., she's 7 miles away from home. At noon, she's 4 miles away from home. And at 1 p.m., she is 0 miles away from home. Write a possible scenario to describe what this graph tells us about Jody's day. I don't know, at 9 a.m., she was driving to work. She was 4 miles away. At 10 a.m., she got to work. And maybe her car got hit. I don't know. At noon, she was on her way home. And then at 1 p.m., she made it home. I don't know. Like you just make up like a silly story like that. And it's like, I'm not, oh gosh. I just don't like these problems. I mean, it makes logical sense. Like the distance away, the distance grows, the distance shrinks. Yeah, we can confirm that. We can draw something like that even if need be. Just I don't like it. But yeah, that's what this problem is really saying. Ah, yes, something more interesting. Here we go. Something a lot more interesting. I'm going to write this stuff down. Number 18. Number 18 wants you to graph this sucker. I need details. I need details. The details that I need are going to involve finding zeros of this particular function, if any, happen to exist. This is a fourth degree polynomial. Let me flip it over here. This is a fourth degree polynomial. It has a certain end behavior to it. It could have up to 4 x-intercepts. We don't know. We have absolutely no idea. Let me take a look at the graph. Let's hope that whoever put this together did something right. Graph. Interesting. Let me zoom in. Zoom in. Ugh, they totally did not. They totally ruined and dashed my hopes and dreams here. I'll tell you why in just a moment. Absolutely gross. Look at that. Look at that. This is gross. I say they dashed my hopes and dreams, but they actually just made this problem 1,000 times easier for you. They made this problem 1,000 times easier for you. Yep, they totally did. I don't like who put this together. Anyway, looks like the bottom of Florida or a fingernail scratching the ground. I don't care. But this is a fourth degree polynomial. It's not exactly a parabola. Here's the only thing that you have to do. Second graph. Let me write down some ordered pairs. This is legitimately all you have to worry about. I'm going to write down as an ordered pair -2, 11. Here, I'll zoom out and show you. -2, 11. -1, 5. 0, 1. 1, -1. Yeah, that's really all I need. I really don't need much beyond that. We're going to draw this thing out in a moment. I just wish they would have given me something a bit more interesting than this. Because you can't actually identify using factoring methods or anything along those lines, or synthetic division. You can't actually identify what these things are going to be. And I am not a huge fan of that. I like identifying things. I'm going to plot -2, 11. Right there. I'm going to plot -1, 5. Right there. I'm going to plot 0, 1. And I'm going to plot 1, -1. Right down there. And based on this, and based on the image on the calculator, I'm going to do a smooth curve. That's the best I can do right there. It's terrible, but that's exactly what this thing is going to look like. I can't tell you how disappointed I am that this question wasn't more interesting to me. But that's honestly all you have to worry about for this problem. Make sure you know how to type this thing in correctly to your graphing calculator. You could even use Desmos if need be. Obviously, in your final exam, you could also use Desmos. Just make sure that you know how to type this thing in correctly. Where you do something like f of x equals x to the 4th plus 2x cubed minus 5x plus 1. And then on Desmos, you can actually identify certain ordered pairs just like that. Draw that thing out, and you got it. Ugh. Let's go back to here. Oh, to here. There we go. Oh, interesting. You guys learned about pie charts back in the day, correct? Like way back in the day, not in my class. Yeah. What's wrong with this pie chart? There's something glaringly wrong with this pie chart. Something that's like, holy crap, whoever put this together had no idea how to make a pie chart. What do you mean?
Like it's supposed to be, isn't it supposed to be out of 100? Like some of them like over 100.
Yeah.
I think I'm also against things.
No, I got you. Well, like I said, that's why I gave you guys the PDF of this. You know, in a school there were 300 boys and 450, or 300 girls and 450 boys in year 1, 285 girls and boys, 135 boys in year 2, 315 girls, 315 boys in year 3. Does the circle graph below correctly represent the number of students in these groups? Why or why not? Not. The percentages are clearly more than 100%.
Okay.
You know what I'm saying? They're more than 100. Yeah, pie charts have to equal 100%. They have to. The whole pie chart is 100%. It's just, again, I'm a little upset at this review. I did not put these questions on the review, but such is life. Number 20. We'll do number 20, and this will be a good step towards the intervention period. As I said, I still wanted to give you the intervention period for this class, in which you do have a quizzes to get done for me, 3 attempts, but it's on sequences and series. So what I would like to do is I would like to take number 20, and I would like to take it a little bit farther than what the question is asking. I want to take it a little bit farther than the question. What the question is asking for number 20 is, what are the next 3 terms? If only life were that simple, where all you had to do is give me the next 3 terms. The next 3 terms, simply put, I'll put it in orange. This looks nice. It is 0.11, 0.13, 0.15. Yay. Those are legitimately the next 3 terms. But I want to go a little bit farther. I just want to go a little bit farther with this arithmetic sequence. Not terribly farther, but just a little bit farther. Those are the next 3 terms. What about a general rule? A general rule for this would utilize that same formula that we have been using over and over and over again, where you can identify clearly the first term, but then you would just have to identify the common difference, which in this case is 0.02. If you can simplify that, that would be fantastic, where you distribute the 0.02 and combine like terms. And it gives you that general rule. Doing something like that is something that you may potentially have to do on this online quizzes that you're going to get done for me. Yeah. Okay. Yep. So we're about to enter the intervention period of this class period. Intervention period of this class period. What a weird way to say that. So what's going to happen is this. As I said, you do have that online quizzes to get done. I think it only said like 3 people had attempted it at this point. But you do have 3 attempts, and it's not due until Wednesday. There are other things that you may possibly owe me, whether it be remediation, enrichment, assignments, post-assessments, things of that nature. The Edge Elastic major. If you need to get those things done, now is the opportunity to get them done. I'm going to leave the live chat open in case you guys have any questions. I've seen the comments that you've left so far. But you have until 12/22. Now, just as a reminder, next week, the last chance that we have to review is on Tuesday the 8th, because you are taking your final exam on Thursday the 10th. Please make sure you're aware of that. Seniors, I need to get senior grades submitted before the 11th or the end of the day on the 11th. So seniors, if you owe me anything, we need to get that done sooner rather than later. Please make sure you're taking advantage of this intervention period. Like I said, you have that quizzes or whatever else you owe me. Let us get to work.
So out of the 3 attempts, did it just pick the best score?
Yes, I double check. Okay, so Google Classroom is supposed to only keep track of the best score. But I always double check against quizzes because sometimes Google Classroom messes up.
doesn't tell you if you get it right or wrong.
That's the point.
I hate that.
Because if you knew if you got it right or wrong, what would stop you from just like, calmly writing down the answers to each individual question and then getting 100 the next time?
If the timer goes out, does it still count as wrong?
No, that has to do with the quiz's points total,
Oh, I guess.
which are meaningless. Not us.
If I get a good grade on the first one, I'm gonna take it.
You can do all 3 attempts, and quizzes will only display for me the best one. So, like, for example, I'm not saying that you have to do this, but let's just pretend the first time you did it, you got like a 90, and you're like, I'm good with a 90. That's fine. You totally don't have to take the next 2 attempts. That's up to you. But I'm just saying, like, if you wanted to, you could be like, well, maybe let me try the next few attempts. Maybe I could get like 95. Maybe get 100. You never know.
That's what I feel like the second time. It's always bomb.
Mm.
See if I get a good grade on the first one.
Can someone check main office? Thank you.
Unfortunately, I don't believe quizzes allows. Wait, does it?
Yeah, if you pause it.
It does allow you to do that, doesn't it?
See a pause button.
Okay. I didn't know that about quizzes. I thought it was like a one-shot deal.
I think you can like you can pause and get out of it. It like lets you reason.
Cool beans. Bless you. minute left. I'm going to sign off on the live stream soon and give you another opportunity to make a comment if you haven't already. We're almost there. 2 more weeks. Unbelievable. I'm being serious when I tell you guys, like, I don't know, for seniors in particular, like my senior year, did I ever tell you what happened my senior year? 9/11.
Oh, yeah, you did.
Yeah. That was the most surreal senior year of my entire life, like of anybody's life, I think, up to that point. I don't know. The only thing I could think about as being more surreal is if you were like a senior in high school during like Pearl Harbor, you know, or something like that. But 20 Well, yeah. And it happened less than an hour from here, you know? But I'm saying seniors or juniors, whatever, today, 20 years from now, you can be like, man, I went to high school through the pandemic. You know what I'm saying? It's going to be nuts. Anyway, we'll see y'all next time. Did I tell you what happened my freshman year?